Have you ever tried to do some math on, I don't know, 1,000 numbers inside a regular Python list? Like maybe you wanted to add 5 to every single number in there. You probably had to write a for loop, right? And it just feels a little clunky, maybe a bit slow. Well, what if I told you there's a way to do that and a whole lot more in a single blazing fast line of code? That's where NumPy comes in.
Okay, so let's get right to the heart of it. The big problem with regular Python lists for heavy-duty math is actually their greatest strength, flexibility. You can think of a Python list like a junk drawer in your kitchen. You can toss anything you want in there. A number, a word, a true-false value, another list. It all fits, but it's not really organized for any specific job. A NumPy array, on the other hand, is like a mechanic's socket set. Every single tool in that box is a number, and they're all the same type. This one simple rule, that everything has to be the same, is its superpower. It's what allows NumPy to be incredibly fast and super memory efficient.
So, here's our game plan for this explainer. First, we're going to meet the heart and soul of NumPy, something called the ndarray. Then, we'll get our hands dirty and create our very first arrays. After that, we'll uncover the magic of broadcasting. This is the thing that makes math feel completely effortless. And finally, we'll learn how to slice, dice, and reshape our data with total precision. Sound good? Let's do it.
All right, let's dive into Section 1. Meet the ndarray. This is the fundamental building block, the solution to all those speed problems we just talked about. So, what is an ndarray? The name stands for n-dimensional array. And really, at its core, it's just a grid of values. It could be a simple one-dimensional line of numbers, a two-dimensional table like a spreadsheet, or it could even have 3, 4, or more dimensions. But here's the golden rule, the most important part. Every single value in that grid has to be the same data type. And that, right there, is the secret sauce that lets NumPy perform these massive, highly optimized calculations behind the scenes. Okay, enough with the theory. The best way to really get NumPy is to just start using it. So let's jump into Section 2 and actually create our very first arrays.
First things first, you are always, and I mean always, going to see import NumPy as NP. It's just the standard way everyone does it. Then, making an array is super simple. You just call np.array and you pass a regular Python list right into it. That's it. NumPy takes that list and transforms it into one of these powerful end arrays. And if you give it a list of lists, like we did here, it's smart enough to know you want a 2D grid.
Now, once you've got an array, you don't have to print the whole thing out to see what's inside. You have these awesome little tools called attributes. Think of it like a dashboard for your data. .dtype tells you the data type, in this case 64-bit integers. .ndim tells you the number of dimensions, we've got 2. .shape is the blueprint, it tells you the size of each dimension, so here it's 2 rows and 3 columns. And finally .size gives you the grand total of elements, which is 6. This is incredibly useful for quickly understanding your data.
And you don't always have to build arrays from lists you've already made. NumPy gives you some really convenient shortcuts. Need an array with 5 zeros? Just use np.zeros. Need a 2x4 grid filled with ones? np.ones. What if you want a sequence of numbers, kind of like Python's built-in range function? Just use np.arrange. These are fantastic for quickly setting up arrays from scratch. All right, let's move on to Section 3. This is where things get really cool. We're about to look at one of NumPy's most powerful and honestly kind of magical features. It's called broadcasting, and it's the reason you can say goodbye to writing all those slow for loops. Just look at this. We make an array of numbers from 1 to 5. Then we just write numbers times 2, and boom! Every single element in that array is instantly multiplied by 2. But wait a second, what's actually happening here? How did Python know to multiply times every single element? We didn't write a loop.
Well, the secret is this concept called broadcasting. The official explanation says that when you have an operation between an array and a single value, which is called a scalar, NumPy cleverly acts as if that single value were a full-sized array of the same shape.
And this slide right here, this is the aha moment. This is what it looks like in your head. When NumPy sees array times 2, it doesn't actually create a new big array in memory. It just conceptually stretches or broadcasts that number 2 across a virtual array that perfectly matches the shape of your original. Then it performs that super fast element-by-element multiplication. You get all the power of a loop without ever having to write one. It's brilliant.
Okay, so we can create arrays and we can do lightning-fast math on them. Now for Section 4, how do we pull out the exact pieces of data that we want? This is all about gaining precision control.
To explore this, let's cook up a little example. Let's pretend we have this 2D array called grades. You can see each row is a different student, and each column is their score on a different exam. We're going to use this grid for the next few examples.
So, how do we grab just one single grade from this table? We use the row-column syntax. The one thing you always have to remember is that computers start counting from 0. So row 2 is actually the third student down, and column 3 is the fourth exam over. Grades 2, 3 gives us exactly what we're looking for, the number 14.
Okay, but what if we want all the grades for just one student, like their whole report card? That's even easier. You just give it one index. Grades 1 gives us that entire second row, all of student 2's scores, just like that. Now, getting a column is where it gets really powerful. For this, we use the colon. The colon is basically a wildcard. It means select everything for that particular dimension. So grades //0 is us telling NumPy, hey, give me all the rows, but only the very first column, column 0. And just like that, you get every student's score for exam 1.
Now, a quick but really important heads up. When you start reshaping arrays, you need to know the difference between a view and a copy. Think of a view, like what you get from the Ravel method, as a window looking into your original data. If you change something through that window, the original data changes too. A copy, which you get with flatten, is like making a photocopy. It's a totally separate thing. You can write all over the copy, and the original stays pristine. This is so important, because if you don't know which one you have, you might accidentally change your original data without meaning to.
Okay, let's wrap this up and put a bow on it. What are the big ideas? First, NumPy arrays are fast and efficient, because everything inside them is the same data type. Second, broadcasting is that bit of magic that lets you do math on entire arrays at once, no loops needed. And third, that slicing syntax with commas and colons gives you surgical precision to grab exactly the slice of data you need.
And really, why do we learn all this? Why is NumPy the absolute foundation of data science in Python? This right here says it all. We are not talking about a small speed bump. We're talking about operations that can be over 100 times faster than what you'd get with a plain old Python list. That is a total game changer. It's the difference between your idea working or not working, between waiting a few seconds for a result or waiting a few hours.
So, I'll leave you with this question. You now have the fundamental tool to handle massive amounts of numerical data with incredible efficiency. You can analyze data from sensors, you can process images, you can build the foundations for machine learning models. The possibilities are huge. The power is in your hands now. So the real question is, what problem will you solve first?